Hi guys, welcome to this easy maths video, and today I am looking at the new AQA GCSE further maths qualification for 2018, and we are looking at the first specimen paper. This is a non-calculator exam and the time allowed is 1 hour and 45 minutes. Question 1, part A, we've got y to the power of 6 times y all over y to the power of m equals y to the power of 4. We need to circle the value of m. Okay, so we can simplify the top part of this fraction by saying that y to the 6 times y is the same as saying y to the power 7, because y is the same as saying y to the power 1, and using our laws of indices, we would do 6 plus 1, which is y to the 7. And then, of course, we're doing all divided by y to the power of m, which equals y to the power 4. We're using the laws of indices. When we divide two of the same numbers which have different powers, we subtract the powers. So if you like, if we were going to form this as an equation, this is just the same as saying 7 minus m equals 4. So m must be equal to 3. And we have an answer of 3. Part B says a to the power of n times a to the power of 5 equals a to the power of 5. Work out the value of n. Well, in this case, n must be 0, because we would get a to the power of 0, which is 1, and then it would just be 1 times a to the power of 5, which is a to the power of 5. So n equals 0. And part C says we've got c to the power of 5 all raised to the power of p is equal to c squared all raised to the power of 6. So I'm just going to rewrite that down here. Using our law of indices, you should know if we have two powers, one that is inside the bracket and one that's outside, we multiply those two powers together. So for the left-hand side of the equation, we're going to get c to the power of 5p, and that's going to be equal to c to the power of 2 times 6, which is 12. Well, now this is basically an equation which just says that 5p is equal to 12, so p must be equal to 12 over 5. So our answer is p equals 12 over 5. Question 2 says solve the cube root of 7x minus 13 equals 2. Okay, so I'm going to write that out again. So what we need to do is we need to get rid of the cube root, so we need to cube both sides. So cubing both sides gives us 7x minus 13 is equal to 2 cubed, which is 8. We can then add 13 to both sides. So we get 7x is equal to 13 plus 8, which is 21. Now we can divide both sides by 7, so x is equal to 21 over 7, which is 3. So answer is x equals 3. Question 3 says 3a all multiplied by 2x minus 1 plus 4 all multiplied by ax plus 5 is equivalent to 60x plus b. So to find the values of a and b, what we can do is we can expand those brackets and then compare coefficients. So if I write this equation out, now we can expand these brackets, so we're going to have the 3a times the 2x, which is 6ax, and the 3a times the minus 1, which is minus 3a, plus 4 times the ax, which is 4ax, plus 4 times the 5, which is plus 20. And that's all equivalent to 60x plus b. Then what I'm going to do is I'm going to collect like terms. So we're going to have 6ax plus 4ax, which is 10ax. And then we're going to have minus 3a plus 20, which is equivalent to 60x plus b. Now to find the value of a, we can compare these coefficients. We can compare 60 with 10a because they are our coefficients of x. So we're going to have 10a is equal to 60, so a is equal to 60 over 10, which is equal to 6. And then to find the value of b, well, we haven't got any other coefficients of x, so we can just say that minus 3a plus 20 is equal to b. So minus 3a plus 20 is equal to b. Well, I know what a is now because I've just worked that out. I know it's 6. So I can say minus 3, all multiplied by 6 plus 20, give me my value of b. So b is equal to minus 18 plus 20, which is 2. So my final answers are A is 6 and B is 2. Question 4, ABC is a straight line with AB to BC is equal to 5 to 2. Work out the coordinates of C. Okay, so I'm going to represent C as x, y. We'll form an equation for the gradient of AC. And what I'm going to do is I'm going to form a triangle with the coordinates AC and work out what are the side lengths of this triangle. So we've got an x coordinate of 3 for A and an x coordinate of x for C. This length must be x minus 3. So this must be 7 minus y. I can then form another triangle using the length BC. And I can say that this length will be x minus 5, and this length will be 5.5 minus y. And using this ratio up here, I know that BC is 2/7 of the line ABC. So what I can do is I can form an equation in x by saying that x minus 5 all over x minus 3 is equal to 2/7. And then I can form another equation in terms of y, saying that 5.5 minus y all over 7 minus y is equal to 2/7. So now I can solve both of these equations to find my value of x. So if I multiply both sides by x minus 3, I'm going to get x minus 5 equals 2/7 of x minus 3. I can then multiply both sides by 7. I'm going to get 7x minus 35 is equal to 2 all multiplied by x minus 3. Then expand brackets on the right hand side. I'm going to get 7x minus 35 is equal to 2x minus 6. If I then add 35 to both sides, subtract minus 2x from both sides, I'm going to get 5x is equal to 29. So x must equal 29 over 5. So that's my answer for x. And then y can then do 7 times 5.5. 7 times 5 is 35. 7 times a half is 3.5. So that's going to be 38.5 minus 7y is equal to 14 minus 2y. I can then add 7y to both sides. I get 38.5 is equal to 14 plus 5y. Subtract 14 from both sides and you get 24.5 is equal to 5y. So y is equal to 24.5 over 5. Okay, I'm probably going to convert these into decimals. So I can multiply 29 by 2 to get 58 over 10, and I can multiply 24.5 by 2 to get 49 over 10. And that, of course, simplifies to 5.8, and that simplifies to 4.9. So they are my answers for x and y. Question 5. Y equals 2x to the power 10 minus 3 all over x squared. Work out dy by dx. Okay, so I'm going to rewrite that equation as y equals 2x to the power 10 minus 3 all multiplied by x to the power minus 2. If I then differentiate this, I can then multiply the 10 by the 2 to get 20 and minus 1 from the power, so I get 20x to the power 9. Then I can multiply the minus 2 by the minus 3, I get plus 6 and minus 1 from the power, so I get 6x to the minus 3. And then I could rewrite this as 20x to the power 9 plus 6 all over x cubed. So that is my final answer. Question 6. Simplify fully 15x squared y minus 5xy squared all over 12x minus 4y. Okay, so we've got 15x squared y minus 5xy squared all over 12x minus 4y. Now we can factorise our numerator, so we can take out factor of 5x and y, and inside our bracket we're going to have 3x minus y. And then we can also factorise our denominator by factorising out the 4, and then we are just left with 3x minus y. Well, these 3x minus y's cancel out, and we are just left with 5/4 of xy. So that is my final answer for question 6. Question 7. ABCD is a rhombus with side length 8 centimetres. Angle ABC is 60 degrees. Work out the area of the rhombus. Give your answer in the form a root b centimetres squared, where a and b are integers. Okay, so with a rhombus, we know that each of the side lengths are equal. So what we can say is that not only the side length of BC is going to be 8 centimetres, but AB will be 8 centimetres, AD will be 8 centimetres, and DC will be 8 centimetres. And what we could do is we could draw a line going through AC which divides this rhombus into 2 triangles. This triangle ABC is actually an isosceles triangle because it has 2 side lengths which are the same. But because this triangle is not a right angle triangle, we need to use the formula for the area of a non-right angle triangle, which is a half AB sine C. But let's say this is small a, this is small c, and this is small b. What we're actually saying is a half AC sine b. So substituting those values in, we get a half multiplied by 8, multiplied by 8, multiplied by sine 60. Now, of course, this is a non-calculator paper, so you won't be able to type in sine 60 into your calculator. But you should know your trig triangles to work out what sine 60 is. And the triangle we use is a right angle triangle, which has an angle of 60 degrees here, an angle of 30 degrees here. We then say the hypotenuse is 2, the base is 1, then the other side, using Pythagoras, must be root 3. And then we can say that sine 60 is equal to opposite over hypotenuse, which is root 3 over 2. So now we've got a half times 8 times 8 times root 3 over 2. Now it's 8 times 8, which is 64, times a half, which is 32. So it's 32 over root 3 divided by 2. But remember, we have 2 triangles. We've got triangle ABC and ADC. So what we're going to end up doing is we're going to end up doing 32 root 3 over 2 multiplied by 2. So these 2's just cancel out, and we are left with 32 root 3. And that is our final answer. Question 8 says the curve y equals 2x cubed minus 3x squared minus 12x plus 6 has a maximum point at L minus 113, has a minimum point at M 2 minus 14, and it intersects a y-axis at N. The curve crosses the x-axis at 3 distinct points. On the axis below, sketch the curve and label the points L, M and N on your sketch. Okay, so first what I'm going to do is I'm going to locate points L and M using the coordinates. So L is our maximum point. So we need to go -1 across and up 13. So I'm going to say that's about here. And I'm going to call that L. Then our minimum point is 2 minus 14. So we go 2 across and minus 14 down. Probably say it's about here. And I'm going to call that M. And then we're also told that it intersects the y-axis at n. Well, it intersects the y-axis when x is 0. So we write when x equals 0, and substitute that into our equation. We're just going to get y equals 6. So it crosses a curve at about this point here. I'm going to call that n. And the other thing we know is because it's a positive cubic equation, it's going to start from the bottom left-hand side. And it should end up looking something like that. So first it's going to intersect the x-axis, and it's going to go through the maximum point, through the y-axis, and back through the x-axis, and it's going to have another turning point where the minimum point is, and then it's going to go back up through the x-axis again, and that should be the sketch of our curve. So it should look something like this. It's only a sketch, so it doesn't have to be exact. The main points in which we're going to get the marks for on this question is making sure it intersects the x-axis 3 times, and you've roughly located your points in the right positions, and that the curve is the right shape. So that's question 8. Angle BCA equals x, angle ACD equals 2x, angle CAD is 3x, and angle CAB is 4x. We need to prove that AC is a diameter. Okay, so what we can see on this diagram is they've labelled where x, 2x, 3x and 4x are. And you should be able to see that ABCD is a quadrilateral. Matter of fact, because it's inside the circle, it's a cyclic quadrilateral. And the opposite angles within a cyclic quadrilateral add up to 180 degrees. Okay, so what we can say is because the opposite angles in a cyclic quadrilateral add up to 180 degrees, we can say that x plus 2x plus 3x plus 4x equals 180. So that's going to be x plus 2x is 3x, 3x plus 3x is 6x, and 6x plus 4x is 10x. So 10x equals 180. So x equals 18 degrees. Now, the other thing you should know using your circle theorems, that an angle at the circumference is equal to 90 degrees. So this should be 90 degrees. So we can say angle ABC is equal to 90 degrees. And we can prove that by saying that the angles in a triangle, so the angles in a triangle add up to 180 degrees. So if we do 180 minus x, which is 18, minus 4x, which is 4 times 18. Well, 4 times 18, that's going to be 4 times 8, which is 32, and 4 times 10, which is 40, so that's going to be 72. 72 add 18 is 90, so we're doing 180 take away 90, which is, of course, 90. And this also proves our statement that we said about ABCD being a cyclic quadrilateral, because if angle ABC is 90 degrees, then angle ADC is 90 degrees. So we can say that as ABCD is a cyclic quadrilateral, angle ADC equals 90. And then to finish it off, we can say the sum of the angles within a semicircle add up to 180. Therefore, AC is a diameter. Question 10, we're told function x is equal to 9x over 2 all to the power of minus 1, and g of x is equal to the square root of 1 minus px cubed, where p is a constant. Given that the function of f, all multiplied by 1/3, is equal to the function of g, all multiplied by 1/3, work out the value of p. So we need to evaluate both of these expressions. So we're going to have function 1/3, that's going to be equal to 9 multiplied by 1/3 all over 2, all raised to the power minus 1. So if we simplify what's inside the bracket first, the 9 multiplied by 1/3 is going to give us 3. So that's going to be 3 over 2 all to the power of minus 1. And anything raised to a negative power gives us the reciprocal of that value. So we get 2 over 3. Now, g of 1/3, that's going to be the square root of 1 minus p multiplied by 1/3 all cubed. And that's the same as saying the square root of 1 minus... Now, 1/3 cubed is 1 over 27. So it's the same as saying 1 minus p over 27. And now what we can do is we can say that 2/3 is equal to the square root of 1 minus p over 27. If we square both sides, we get rid of the square root. So we get 4 over 9 is equal to 1 minus p over 27. And then we get p over 27 is equal to 1 minus 4 over 9, which is 5 over 9. So to work out p, we need to multiply both sides by 27. So we get p equals 27 times 5 divided by 9. Well, the easiest way in going about this is saying that 27 divided by 9 is 3, so we're doing p equals 5 times 3. Well, that's 15. So our final answer is 15. Question 11. A circle centre C touches the y-axis at the point 0, 2. The line y equals k intersects the circle at the points 1k and 5k. Work out the equation of the circle. Okay, so when we're working out the equation of a circle, the general form for the equation is y equals x minus a squared plus y minus b squared all equals r. Now this a and b term represents the centre of the circle. Oh, that should say r squared. And r squared is the radius of the circle. So how are we going to find out the centre? Well, the y-coordinate is very easy because we know that the circle touches the y-axis at the point 0, 2, and that lines up with the centre. So this is going to have a y-coordinate of 2. But to work out the x-coordinate, what we need to say is, well, this line going from the centre to this point where we've got the line y equals k intersecting the circle, well, both of these lines are going to be the same length because they represent the radius of the circle. So that's going to have a value of r and that's going to have a value of r, which means that this is an isosceles triangle. So that would mean that these two angles would be the same. So what we can do with an isosceles triangle is we can divide it into two right angle triangles. The line y equals k is basically a chord going through the circle. The point at which we divide this triangle into two right angle triangles, that's the midpoint of this chord. So it's just halfway between the point 1k and 5k. To find the x value, we're doing 5 plus 1 divided by 2, which is of course 3. So this point here would have a value of 3k. And of course that's the same x value as we have for c. So our centre is going to be 3, 2. Now, how are we going to work out the radius? Well, the radius is very easy because we know that the circle touches the y-axis at 0, 2, and we've got the centre, which is exactly parallel to the y-axis. So the centre is 3 units away from the y-axis. So r is equal to 3. But as part of our equation, we need to square r. So our equation is going to be x minus the x-coordinate of our centre, which is 3, all squared, plus y minus the y-coordinate of our centre, which is 2, all squared equals the radius, which is 3, squared. And that gives us an answer of x minus 3 all squared plus y minus 2 all squared equals 9. And that is our final answer. Question 12. AB equals 4 centimetres, AC equals 7 centimetres, and cos x equals minus 2 over 7. Work out the length of BC. Okay, so we've got two lengths, and we've got an angle which is opposite the length that we need to find. So therefore we can use the cosine rule. The formula for the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Now let's call this a, this side b, and this side c. So we need to find side a. We can just use this formula. We don't have to change any of the terms around. And we can say that a squared is equal to 7 squared plus 4 squared minus 2 times 7 times 4. Now times cos, rather than a, it's x. So I'll call it cos x. We have an answer for cos x. Cos x is equal to minus 2 over 7. So we can replace this with minus 2 over 7. Okay, so now, if we simplify this, we're going to get 7 squared, which is 49, plus 4 squared, which is 16, minus 2 times 7 times 4 times minus 2 over 7. Now, what I'm going to do is these 7s are going to cancel out. So that's going to make it a little bit easier. And all we're doing is minus 2 times 4 times minus 2. Well, minus 2 times minus 2 is 4, and 4 times 4 is 16. So it's just plus 16. Now, and if we simplify this, we get 49 plus 16, which is 65, and 65 plus 16 is 81. And then we just got to do the square root of both sides. So a is plus or minus 9, but we know we can't have a negative side. So we just say a is equal to 9. And therefore that's our final answer. Question 13, rearrange t equals 3w cubed plus a all over w cubed minus 2 to make w the subject. Okay, so I'm going to rewrite that down here. What we need to do first is we need to multiply both sides of the equation by w cubed minus 2. So that's going to be t all multiplied by w cubed minus 2 is equal to 3w cubed plus a. Now, and if we expand this bracket on the left-hand side, we're going to get w cubed t minus 2t is equal to 3w cubed plus a. Now we need to have all of the w's on one side. So if we subtract 3w cubed from both sides and then add the 2t, so rather than having it on the left hand side, we've got it on the right hand side of the equation. So what we're going to have is w cubed t minus 3w cubed is equal to a plus 2t. And then what we can do is we can factorise w cubed from this equation. So we get w cubed all multiplied by t minus 3 is equal to a plus 2t. And now just to get w cubed on its own, we need to divide both sides of the equation by t minus 3. So we get w cubed is equal to a plus 2t over t minus 3. Now, I'm just going to continue writing this up here. All what we need to do, because we don't want w cubed on its own, we want w, so we're going to have to cube root both sides. So we get w is equal to the cube root of a plus 2t all over t minus 3. And that is our final answer. So w equals the cube root of a plus 2t all over t minus 3. Question 14, rationalize and simplify the square root of 3 minus 7 all over the square root of 3 plus 1. Give your answer in the form of a plus b root 3, where a and b are integers. If I just rewrite the expression. What we need to do is we need to multiply this fraction by this bottom number, but we need to change the sign. So what we'd be doing is multiplying it by root 3 minus 1 all over root 3 minus 1. And what we end up doing is if we put brackets around these two fractions, we're doing root 3 times root 3, which is 3, then root 3 minus 1, which is minus root 3, minus 7 times root 3, which is minus 7 root 3, and then minus 7 times minus 1, which is plus 7. And then that's all over root 3 times root 3, which is 3, root 3 minus 1, which is minus root 3, 1 plus root 3, which is plus root 3, and 1 times minus 1, which is minus 1. Now we can simplify both the denominator and the numerator of this fraction. So we get the 3 plus the 7, which is 10, and we get the minus root 3 minus 7 root 3, which is minus 8 root 3. The denominator, we've got 3 minus 1, which is 2, and then the minus root 3 and the 3 simplify to 0. So we got 10 minus 8 root 3 all over 2. So we just need to divide each term by 2. So we get 5 minus 4 root 3. And that is our final answer because it's in the form of a plus b root 3, where a is 5 and b is minus 4. Question 15. Point A lies on the curve y equals x squared plus 5x plus 8. The x-coordinate of A is minus 4. Show that the equation of the normal to the curve at A is 3y equals x plus 16. So first I'm going to work out the y-coordinate of A by substituting minus 4 into this equation. So we get y equals minus 4 squared plus 5 all multiplied by minus 4 plus 8. That's y equals 16 minus 20 plus 8. 16 minus 20 is minus 4, minus 4 plus 8 is 4. So the coordinate of A is minus 4, 4. So to work out the equation of the normal, first we need to work out the equation of the tangent and then find the perpendicular gradient. So we can find the equation of the tangent by differentiating our equation. So the derivative will be equal to 2x plus 5. We can then substitute minus 4 into this equation to get our value for the gradient. So we get dy by dx is equal to 2 all multiplied by minus 4 plus 5. 2 times minus 4 is minus 8. Minus 8 plus 5 is minus 3. So the gradient of the normal is going to be perpendicular to minus 3. So what we say is we take the negative reciprocal of the gradient of the tangent. So the gradient of the normal is going to be 1/3. And now what we can do is, because we know that the normal passes through point A and it's got a gradient of 1/3, we can use the formula y minus y1 equals m bracket x minus x1 to work out the equation of the normal. So we're going to get y minus 4 is equal to 1/3 all multiplied by x minus minus 4, which is going to be plus 4. Then we can multiply both sides of the equation by 3. So we get 3y minus 12 is equal to x plus 4. And then we can add 12 to both sides of the equation, and we get 3y is equal to x plus 16. And that is what we had to show. Part B says the normal at A also intersects a curve at B. Work out the x-coordinate of B. Well, we know the equation of the curve is y equals x squared plus 5x plus 8. And we've worked out that the normal to the curve is 3y equals x plus 16. So what we've got here is we've got a quadratic term and a linear term. And we need to solve these simultaneously to work out what our x-coordinate is. So if I write down those two equations, which is y equals x squared plus 5x plus 8, and then 3y equals x plus 16. Well, what we can do is we can substitute this quadratic function into our linear function. Where we've got 3y, we can replace the y with x squared plus 5x plus 8. So we get 3 all multiplied by x squared plus 5x plus 8, which is equal to x plus 16. Expand this bracket, we get 3x squared plus 15x plus 24 equals x plus 16. And then we get 3x squared minus x from both sides, we get plus 14x, and minus 16 from both sides, we get 8 is equal to 0. In order to factorise this, I could use the quadratic formula. But because I know that this equation also passes through the point A, I know that this equation is going to factorise to x plus 4 multiplied by something. Well, that something must include a 3x in order to get x times 3x, which is 3x squared. So this must be 2. Because if this is 2, then we'll get 4 times 2, which gives us the 8. So the solutions to this equation are going to be x minus 4 or x equals minus 2 over 3. Well, we know x equals minus 4 is the coordinate of A, so the x coordinate of B must be minus 2/3. So x equals minus 2/3. Question 16, the coefficient of the x to the 4 term in the expansion of 2x plus a all to the power of 6 is 60. Work out the possible values of a. Okay, so because this expression is in the form of a plus b all raised to some power n, we need to use Pascal's triangle. Now, you should know that Pascal's triangle looks something like this. So we start off with a 1, and then we write a 1 on either side, so our outside is always going to have 1s. And then what we say is we do 1 plus 1, which is 2, and we add another 1 on the end, and then we write another 1 on the end, write another 1 on the end here. We add these two terms, which is going to be 3. We add these two terms, which is also going to be 3. Then we repeat the process, so this is going to be a 1. We add these two terms, so that's going to be a 4. We add these two terms, so that's going to be 6. We add those two terms, that's going to be 4. And we're going to have the 1 on the outside. And if we do it again, add these two terms, we're going to have 5. Add these two terms, we're going to have 10. Add these two terms, we're going to have 10 again. Add these two terms, we're going to have 5, and then we're going to have another 1. Right, and that's Pascal's triangle. I mean, it can keep going on forever. So the way in which Pascal's triangle works is all the numbers are our coefficients of the expansion. So this is what happens when n is 0. So any expansion, if it's to the power of 0, is going to give us an answer 1. Then we say anything raised to the power of 1 is going to give us the coefficients of 1. And this is anything raised to the second power, anything raised to the third power, anything raised to the fourth power, anything raised to the fifth power. But of course, our binomial expansion goes up to the sixth power, so I'm going to write out another row of Pascal's triangle. So this is going to be 1. We're going to do 1 plus 5, which is 6, 5 plus 10, which is 15, 10 plus 10, which is 20, 10 plus 5, which is 15, 5 plus 1, which is 6, and then we're going to have the 1 here. So this is going to be a binomial expansion to the 6th power. And what's going to happen is the 1, 6, 15, 20, 15, 6 and 1 are all our coefficients. So if I write out the expansion of 2x plus a all to the power of 6, what's going to happen is we're going to get 2x all to the power of 6 multiplied by a to the power of 0 multiplied by 1, because 1 is this coefficient. Then we're going to do plus 2x to the power 5 multiplied by a to the power 1 multiplied by the 6, which is this coefficient, plus 2x to the power 4 multiplied by a squared, then multiplied by 15, which is this coefficient. And I'm going to stop there because, as you can see, this is our x to the power of 4. This is our term which will have the coefficient of x to the power 4. So we've got 2x to the power 4 multiplied by a squared multiplied by 15. And this is going to be equal to the coefficient which we know is 60. So if we expand the left hand side out, we're going to get 2 to the power 4, which is 16, x to the 4 a squared 15 equals 60. Now what I can do is I can get rid of this x to the power 4, because what we're technically doing is we're equating coefficients. So this is just going to be 16 a squared multiplied by 15 equals 60. Well, I know 15 times 15 is 225. So 16 times 15 is going to be 225 plus 15, which must be 240 a squared, and that's equal to 60. So now if we divide both sides by 240, we're going to get a squared equals 60 all over 240. Now divide top and bottom by 60, we are going to get 1 over 4. So a squared is equal to a quarter. And if we do the square root of a quarter, which is going to be plus or minus, That gives us a is equal to plus or minus a half. So that is our final answer for a. So a can equal a half or minus 1/2. Question 17. Solve the simultaneous equations 2a plus b minus c equals 8, 4a minus 3b minus 2c equals minus 9, and 6a plus 3b plus c equals 0. Okay, so I'm going to write this as our first equation, this is our second, and this is our third. And what I'm going to do is I'm going to solve these equations by the process of elimination. So what I can see is equation 2 and equation 3 have the same coefficient for b, which is 3. So what I can do is I can add equation 2 and equation 3 so that the minus 3b and the 3b cancel out. So if I do equation 2 plus equation 3, it's going to be 4a minus 3b minus 2c equals minus 9, and 6a plus 3b plus c equals 0. So add these two equations together, we get 10a minus c equals minus 9. Then we need to take a different pair of the equations. So what I'm thinking is if we take equation 1 and equation 3, because if we look at the c terms, the coefficient is the same. We've got minus 1 and plus 1. So if I do equation 1 plus equation 3, then that's going to be 2a plus b minus c equals 8. Then we've got 6a plus 3b plus c equals 0. So we add these, I get 8a plus 4b equals 8. Now what we've done is we've taken an equation where we've eliminated the b's and we worked out another equation where we've eliminated the c's. So we're going to have to find one more equation where we can eliminate the a's. Well, in order to do that, I'm thinking if we take equation 1 minus equation 2. But what we're going to have to do is we're going to have to multiply equation 1 by 2. So if we multiply equation 1 by 2, we're going to have 4a plus 2b minus 2c is equal to 16. And then equation 2 is 4a minus 3b minus 2c equals minus 9. Subtract these two equations. Well, the 4a's cancel out, and then we've got 2b minus 3b, which is 5b. The minus 2c's are going to cancel out, and then we're going to have 16 plus 9, which is 25. And this is quite handy because with this equation, both of the a's and both of the c's cancel out. So now we've got a very simple equation where we can work out the value of b by dividing both sides of the equation by 5. So obviously b is 25 over 5, which is 5. So that's our value for b. And now what we can do is we can work out our value of a by substituting 5 into this equation here, 3a plus 4b equals 8. So if I rearrange this equation to work out the value of a, it's going to be a is equal to 8 minus 4b over 8. Well, b is 5, so it's going to be 8 minus 20 over 8. 8 minus 20 is minus 12 over 8. Well, that's going to simplify to minus 3 over 2. This is minus 1.5. And then to work out c, we can just use this first equation we worked out. So if I write it up here, it's going to be c is equal to 10a plus 9. Or a is minus 3 over 2. And 10 times minus 3 over 2, well, that's going to be doing 10 divided by 2, which is 5. And then 5 times minus 3, which is minus 15. So c is minus 15 plus 9. So c must be minus 6. Question 18, solve x to the power of minus 2 over 3 equals 12 1/4. So this is what we've got to solve. And of course we want to find the value of x. Now what I'm going to do first is I'm going to convert 12 1/4 into a top-heavy fraction. So we can multiply the 12 and the 4, which is 48, and then add the 1. So we get 49 over 4. So it's going to be x to the power of minus 2 over 3 equals 49 over 4. Well, now using our laws of indices, we can convert this x to the power of minus 2 over 3 to 1 over x to the power of 2 over 3. Of course, that's equal to 49 over 4. And now what we can do is we can flip both sides of the equations around. So rather than having 1 over x to the power of 2 over 3, we can have x to the power of 2 over 3 over 1. So what we're actually saying is x to the power of 2 over 3 is equal to 4 over 49. And now what we need to do is we just need to get x on its own. Well, again, using the laws of indices, what we can do is if we take x to the power of 2 over 3 and raise all of this to the power of 3 over 2, then what's going to happen is you're multiplying the powers together. So you're going to get 2 over 3 times 3 over 2, which is going to give us 1. So x to the power 1 is obviously just x. So whatever we do to the left-hand side of the equation, we've got to do to the right-hand side. So we're going to have 4 over 49 all to the power 3 over 2. So to find x, we can square root both the numerator and the denominator and then cube those values. So we're going to do the square root of 4, which is 2, the square root of 49, which is 7. So it's going to be 2 over 7 all cubed, which is going to be 2 cubed, which is 8, and then 7 cubed, well 7 squared is 49, and 49 times 7, we've got 9 times 7, which is 63, 7 times 40, which is 280, so that is 343. So our answer is x equals 8 over 343. Question 19. Function x equals 2x cubed minus 12x squared plus 25x minus 11. Use differentiation to show that f of x is an increasing function for all values of x. Okay, so if we differentiate this function, so we do f dash x, we're going to get 6x squared minus 24x plus 25. Now, we haven't got any values of x to substitute in this equation to show that it's an increasing function. So what we can do is if we can prove that this equation has a minimum point rather than a maximum point, which we know it does because it's a positive quadratic equation, we can say that f of x is an increasing function for all values of x. So we can do that by completing the square. So what I'm going to do is I'm going to factorise 6 from this equation. So we take out a factor of 6, we're going to have x squared minus 4x plus 25 over 6. Now we need to half the coefficient of x. So we get x minus 2 all squared, and then we're going to square the 2, subtract it from 25 over 6, so we're going to get minus 4 plus 25 over 6. And now we can multiply through by 6. So we're going to get 6 all multiplied by x minus 2 squared, and 6 times minus 4 is minus 24, and 6 times 25 over 6 is plus the 25. So now we've got 6 all multiplied by x minus 2 squared plus 1. And we can say that the minimum point will be at 2, 1. And then what you could do is we could sketch a little graph, and we know that the minimum point is going to be at 2, 1. So it's going to be roughly here. So the curve is going to look something like that. And of course, you can see that the domain can take any real values of x. So we can say, therefore, as function x has a minimum point, it is an increasing function for all real values of x. Question 20 part A, show that 2 cos squared theta is equivalent to 2 minus 2 sine squared theta. So using our trig identities, we know that sine squared theta plus cos squared theta is equal to 1. So what we can do is we can rearrange this equation to make cos squared theta the subject. So we get cos squared theta is equal to 1 minus sine squared theta. So we can replace 2 cos squared theta with 2 all multiplied by 1 minus sine squared theta. And of course, if we expand out this bracket, we get 2 minus 2 sine squared theta. And part B says, hence, solve 2 cos squared theta plus 3 sine theta equals 3. Okay, so what we can do is we can replace the 2 cos squared theta with what we worked out in part A, which is 2 minus 2 sine squared theta. So we're going to have 2 minus 2 sine squared theta plus 3 sine theta equals 3. And then what we can do is we can bring the 2 sine squared theta and the 3 sine theta over to the right hand side. So we get 2 sine squared theta minus 3 sine theta, and then we can subtract the 2 from both sides, so we get plus 1 is equal to 0. And now what we can do is we can let some constant equal to sine theta. So I'm going to say let x equal sine theta. So we can say 2x squared minus 3x plus 1 equals 0. Well, of course, this only has factors of 1. So we make that 2x, that x, that must be minus 1, and that must also be minus 1. And if we expand those brackets, we get 2x squared minus 2x minus x, which is minus 3x plus 1. So that works. But what we need to say is, because the solutions of this equation are x equals a half or x equals 1, we now need to replace x with sine theta. So we get sine theta equals a half or sine theta equals 1. So in order to find solutions for theta, I'm going to use the sine graph. Now, if we do a sketch of the sine graph, so it will look something like this. That point's 180 degrees, that's 360. So between here, that must be 270, and this must be 90. And that has a value of 1, and that has a y value of minus 1. So using this graph, you should be able to see that sine of 90 gives us an answer of 1. So therefore, we can say that theta is equal to 90. Now, to find the inverse of sine of a half, what I think I'm going to do is I'm going to use our trig triangles. If we say this is 60 and this is 30, that's 1, that's 2, that's root 3. Well, you should be able to see, if we take 30 to be our opposite angle, we can do opposite, which is 1, divided by the hypotenuse, which is 2. So theta must be equal to 30 degrees. Now, we need to find values of theta which are between 0 and 180. We can use the sine graph and say, well, this is roughly 30, and that gives us an answer of a half. Then because this curve is symmetrical, we must also have another answer for a half, which is 180 minus 30 degrees, which is 150. So therefore, theta is also 150. So our answers of theta are 30, 90, and 150. Thanks for watching. Don't forget to subscribe. You can check out my other videos on this page. And also, if you've got any questions or any video suggestions, just leave a comment down below.